There we go. So number 13 says, does each set of numbers form a Pythagorean triple? Explain. So when they give you three numbers, a Pythagorean triple has to work in the Pythagorean theorem. What's the Pythagorean theorem? A squared plus B squared equals C squared. So basically they're saying, does 4 squared plus 5 squared equal 6 squared, right? We're trying to figure that out. That's just plug it into your calculator. 4 squared plus 5 squared is 41. 6 squared is 36. 41 does not equal 36. So does it form a triple? You would say no, and this is plenty explanation. Okay. Which number always stands alone in a triple? The biggest one, right? It's got to be the biggest one by itself. You don't have to try any other combination. If the biggest one squared does not equal the sum of the two smaller ones squared, it won't work, okay? So just make sure the biggest one is by itself. Okay, find the value of x and then simplest radical form. So in this one, x represents what variable in the Pythagorean theorem? A or B. Right, it cannot be C because this has to be C. Hypotenuse is always C. So this is going to be x squared plus 4 squared equals 6 squared, or you can do 4 squared plus x squared equals 6 squared. So take away 4 squared, and you get x squared equals 36 minus 16, so 20. Okay. They want simplest radical form. 20 is not a perfect square, so you need to break this into the perfect square and the non-perfect square. What is that with 20?
2 rad 5.
It's 2 rad 5. Rad 4 and rad 5 gets you 2 rad 5. Okay. Number 20. Okay, so now this one, you have two unknowns. The beautiful thing is they're the same unknown, right? These are both x. So you're going to say x squared plus x squared equals 6 squared for the Pythagorean theorem. What is x squared plus x squared? 2x squared, not x to the fourth. Okay, don't add your exponents. It's like saying an apple plus an apple is 2 apples, right? 2x squared equals 36. Divide by 2. So x squared is 18. And then you can break it into simplest radical form. What is that in simplest radical form? Right, rad 9 and rad 2 would be 3 rad 2. Okay. 23. This one says a walkway forms one diagonal of a square playground. The walkway is 24 meters long. So you're looking at a square playground. Sorry for the janky square. The diagonal is 24 meters long. To the nearest meter, how long is a side of the playground? So this would make a right angle because it's a square, right? They're looking for what is that length. Do you see how you can set that up to solve it?
2x squared equals 24.
Right, same as the last one, right? These would both be x because it's a square. So 2x squared equals 24, so divide by 2. So x squared is 12, and then take the square root of that. Well, the square root of 12 would be rad 4 and rad 3, so 2 rad 3 would be your setup. Now this one, because it's a real world problem, my guess is the book just gave you an actually it probably said to the nearest meter. So you didn't even have to do simplest radical on that. Really all you had to do was plug in the square root of 12 in your calculator, and that will give you the decimal version, which is actually not going to be a decimal because it says nearest meter. I don't know what that comes out to. Anyone know? 7?
17.
17. Well, rad 3, probably more like 7-ish.
Yeah.
That's not up there. What is it?
It was 17.
17. That seems too big. Sure enough, 17 meters. Oh, we had more, didn't we? Yes. Okay, 34 says in a parallelogram, think about what you know about a parallelogram, right? Opposite sides are parallel, but opposite sides are also what? Equal, right? Opposite angles are congruent, consecutive angles are supplementary. You know lots of things about parallelograms. It says RS, Okay, so first of all, I would just draw a parallelogram. It's asking if it's a rectangle. I would just draw it to look like a rectangle, even though we don't have any idea if it's a rectangle, okay? Because then you can visualize it. So R, S, T, W. It says RS is 7, ST is 24, and RT, which is a diagonal, is 25. Is that a rectangle? Now here's the thing. If this is going to be a rectangle, we have to have what? What's the definition of a rectangle?
4 sides.
Not 4 sides. 4 right angles, right? So it's a quadrilateral with 4 right angles. That means this would have to be a right angle. And because it's a parallelogram, if one is a right angle, then all 4 will be right angles, right? How do I determine if that's a right angle? Pythagorean theorem. Yeah, plug it in. Does 7 squared plus 24 squared equal 25 squared? Does that look like a triple to you? That is a triple. 7, 24, 25. Not the most common one, but definitely one that shows up quite a bit. So yes, it would be a rectangle. This is a lovely explanation as to why. Okay, 38. Find the value of x if your answer is not an integer. Put it in simplest radical form. With this setup, okay, when we draw this perpendicular in, if you recall, in an isosceles triangle, what does this line that is perpendicular do to this side over here? It's a bisector, right? So this would be 1. So we're looking at this triangle. It would be 1 squared plus x squared equals 3 squared, just another Pythagorean theorem. So x squared equals, if we take away 1, 9 minus 1 is 8. That's not a perfect square, so we're going to put it in simplest radical form. That would be the square root of 4 and the square root of 2. So 2 times the square root of 2 would be your value for x. Okay. And then the last one, for each pair of numbers, find a third whole number such that the 3 numbers form a Pythagorean triple. Okay, so here's the deal. We don't have the third number, so we don't know if we're missing a hypotenuse or if we're missing a leg. So if your triangle were set up like this, 12 and 37, then this would be your C, right? So you could try 12 squared plus 37 squared should equal C squared. If you plug that in, 12 squared plus 37 squared, you get 1513 equals C squared. So square root that. The square root of 1513 is this number. Oops. And it just keeps going, okay? Not a triple, right? If you get a decimal, it's not a triple, which means what's going to be our hypotenuse? 37. Put the 37 here. We'll call this B instead. So 12 squared plus B squared equals 37 squared. Try it this way. If you take away 12 squared, so 37 squared minus 12 squared is B squared equals 1225. That looks like a nicer number. Take the square root of 1225 and you get B is 35. So that means 12, 35, 37 is a Pythagorean triple. Okay? Any questions on that? Okay, so we're going to start today with what's called a 45, 45, 90 triangle. And those are just the angle measures of the triangle. Okay? So I want you to look at this 45, 45, 90 triangle down here. This one. Can you tell me anything about that triangle?
Right triangle.
It's a right triangle. Luke.
Isosceles.
It's isosceles. How do you know it's isosceles?
Because both the angles are equal.
You have congruent base angles, right? So a 45, 45, 90 triangle is always an isosceles triangle. Now here's the thing. that means, and you guys did this a couple times in the homework, they were setting you up for today's lesson. You didn't know, but they were. This leg and this leg are always congruent in a 45, 45, 90, right? So here's what I want you to see. If I call those both L and I call this H, the Pythagorean theorem, because this is a right triangle, the Pythagorean theorem still says L squared plus L squared will equal H squared, right? This is a leg, and a hypotenuse. Okay, so L, and H is what I'm using for today. Now, if we simplify that, I could say L squared plus L squared is 2L squared equals H squared, right? And if I take the square root of both to figure out what is the hypotenuse, if I want to know what the hypotenuse is in relationship to my other sides, if I were to square root both sides right now, I would get the hypotenuse equals the square root of 2. And what's the square root of L squared? L, right? If you square root something that's been squared, it's just that number that we already have. So I'm going to put that out in front. That means in every single 45, 45, 90 triangle, there is always a relationship to your leg length, okay? Whatever the length of this leg is, whatever the length of this leg is, and now the hypotenuse is that length of the leg times the square root of 2 every single time, okay? If you can remember this setup, you won't have to do the Pythagorean theorem much at all today. If you don't remember that setup, you could always do the Pythagorean theorem. It's a lot more work, okay? This is gonna save you a whole lot of time. But just know that if today's a struggle, you have the Pythagorean theorem in your back pocket. You may use it anytime, okay? You just gotta think about what we know and what we don't know. Okay, so let me show you how this little shortcut is going to come into play quite nicely for you. Look at this first example. You have a right triangle, a 45, a 90, that means this is 45 also, okay? They don't have to give you all of them to know it's a 45, 45, 90, right? If you have a 45 and a 90, your only option is another 45. Can anyone tell me what X is? It's 8, right? If this leg is 8, then this leg is 8. Okay, now think back to here. What is Y? 8 times the square root of 2. Isn't that lovely? 8 times the square root of 2. It will always be the length of the leg times the square root of 2. Now, if you didn't remember that shortcut, you could have done this, right? 8 squared plus 8 squared equals Y squared, and you could have walked through the Pythagorean theorem, and you would have gotten 128 equals Y squared, and then you would have square rooted it, and when you break down 128, you don't need to write this because most of you are not going to use this. But I just want you to see where you have a backup if you struggle with this, okay? 64 and 2, 64 is the perfect square, 8 rad 2, what do you know? I got the same answer. So you can either do all this work or you can do no work. Hi, thank you. How's it going? Good. Questions on that? Isn't that a lovely shortcut? It's a lovely shortcut. Okay, take a look at this one. I know in a triangle that's 45, 45, 90 that I have L, L, and L rad 2. What is X? It's 5, right? If I know this is L rad 2, then L is 5. So that means this leg over here, my X is 5, and this leg over here, my Y is 5. Isn't that so much nicer than having to go X squared plus Y squared equals 5 rad 2 and then go, oh, I know they're the same, so X squared plus X squared equals 5 rad 2, and then solve for that? It's a pain in the butt, right? We don't want the pain. We want the easy route. Yeah, so X is 5, Y is 5. Okay, So those are the, like, you can look at it and you can see the answer, those types of problems. There's a few where there's a little more work that goes into it, but it's still pretty straightforward, and there's actually a shortcut to the shortcut that you're going to be like, oh, yep, going to do that every time. Let me show you. On a problem like this, it's a 45, 45, 90, right? So this is L, L, and L rad 2, okay? Now they told us what the L rad 2 side is. We need to figure out what L is. What is the length of X in this case? Here's what you're going to do. I know this side is L rad 2. So I know 10 is equal to my L rad 2. Now it's just algebra. How do you isolate L right now? How do we solve for L?
You divide it by L rad 2. Not L rad 2, just rad 2.
Just rad 2. Divide by rad 2. So divide by rad 2 on both sides. This is 1, so it goes away. But we can't leave a radical in the denominator, right? How do you get a radical out of the denominator? Do you remember? We called it rationalizing in Algebra 1. This is where you multiply by the denominator over itself, because really we're just multiplying by 1 then. So when we do that, what we get is 10 rad 2 on top. What's this? Rad 2 times rad 2. 2, right? It's rad 4, which is 2. Okay, keep going. That simplifies to, what's 10 rad 2 divided by 2? 5 rad 2. Okay, and that is an acceptable answer because there's no radical in the denominator anymore. So your L, or in this case X, is 5 rad 2. Okay, now here's what I want you to see. We started with a 10 as our L rad 2 side. When we solved for the leg, it became 5 rad 2. Okay, just note that. Okay, let's try it over here. What are we going to set 14 equal to? Which side of our 45, 45, 90 is the 14? The hypotenuse. And what is the hypotenuse in a 45, 45, 90? L rad 2. So you're going to say 14 equals L rad 2. How do you solve for L? You divide by rad 2. Okay, so this is gone. Then what? Weston, you're going to want to know how to do this. Multiply by what?
Rad 2 over rad 2.
Multiply by rad 2 over rad 2, right? We're just multiplying by 1, so it's not changing a value. So now you have 14 rad 2 on top. And what on bottom? 2. Okay. Simplify that. What does it become? 7 rad 2. Okay. This is 7 rad 2. This is 7 rad 2. Okay, now look at this. If your hypotenuse is a whole number, what do you notice about the leg? Divided by 2 times rad 2, right? So if I were to give you a 45, 45, 90, this is a shortcut to a shortcut. I should not tell you these things, but I do. If that's 22, can you tell me what this is right now? 11 rad 2, right? You divide it by 2 and you multiply by rad 2. Okay, now here's the little kicker. What if this is 23 instead? So we don't love decimals with radicals like that. So all you do, think about what you're doing. You're cutting it in half and you're multiplying by rad 2, right? So we're going to say 23 rad 2 and divide it by 2, and that would be your side, right? Multiply by rad 2, divide the whole number by 2, you'll get your answer. So yes, 11.5 wouldn't be the worst answer ever. This is the better answer. This is the answer the book's going to give you. So if it's an odd number, just put it times rad 2 over 2. And if it's an even number, you'll do the same thing, but you just need to reduce, right? If it's 24 over 2, it's going to become 12. Does that make sense? Okay, now all of that is a shortcut and a shortcut to the shortcut. What could you do every single time on these? Pythagorean Theorem. Yes, okay? Because here's the deal. Even though in this problem, there's an x and a y, what do you know about that x and y? They're the same. So if you get stuck, just say x squared plus x squared equals 14 squared, right? Just substitute this for an x because we know they're the same. And then you can solve that for x every single time. It's a lot more work, but it will work. Questions on that? Yeah.
What would you say we have to do for an odd number?
An odd number, you're going to divide by 2 and multiply by rad 2. And an even number 2. So like if I had 27, right? If my hypotenuse was 27, then this is going to be 27 times rad 2 divided by 2. So you always multiply by rad 2 and divide by 2 no matter what. It's just that if it's an even number, if it was 26, and I did that, 26 rad 2 over 2, that can simplify to 13.
Okay, but you wouldn't simplify odd.
You can't simplify the odd, yeah, because we don't want a decimal answer. Good on that? 45, 90s. Okay, so this last one here, this was a question in your homework, right? It was a playground in your homework. Now it's a courtyard. Courtyard shaped like a square with 250-foot sides. What's the distance from one corner to the other? Okay, now when it's a real world situation, they want an actual distance, not a radical distance, because no one talks in radicals when we're talking distance. Have you ever heard someone say, it was 250 rad 37 feet long? It just doesn't happen. So if this is my setup, what will x be? You can give me the radical version right now if you want.
45 rad 2.
It'll be 250 rad 2, right? This is your leg. Your other leg would be the same because it's a square. So this, meaning a 45 degree, because we just cut a square in half, right? That 90 got cut in half. That's going to be our L rad 2 side. So 250, 250, that makes that x side 250 times rad 2. Now, like we said, in a real world situation, we don't want a radical. So 250 rad 2, if you plug that in, you get 353.5533. It keeps going. We'll say round to the nearest tenth of a foot. So this would be 353.6 feet from one corner to the other. Okay. And I just remembered that in the homework for tonight, people always freak out about one, and I'm going to pull it up real fast because I want you to understand before you jump in. Is it that one? Okay, this. People see a radical there, and they're like, wait, that's not the radical side. It doesn't matter where the radical is. It's the relationship between everything, right? So in a 45, 45, 90 like this, what is x?
Rad 2.
It's rad 2, okay? So what is y?
2.
Y.
Because it's
Because
square
one-
root.
It's the length of the leg times rad 2, right? It's rad 2 times rad 2, which is rad 4, which is 2. Okay, so don't let a radical in a weird spot freak you out. Follow the rule. The rule is leg, leg, leg rad 2. If you stick with that, it'd be 2. Mm-hmm. Yeah, your value for y is just 2. Okay? All right, that's all I got for you.